All right. Welcome, everyone. This is our Science of Ungulates. So like I mentioned, this is our last one for the winter series, and then we will be starting up again in June. So today we're going to be talking about ungulates. So like I mentioned earlier, if you don't know what that word is, or it's not a very familiar word that you use quite often, it's okay. A lot of people don't use that word, but one, it sounds cool, and two, it's a new like sciencey word that we just all learned today. So ungulates are mostly hoofed animals, and we'll talk about where that kind of falls in as far as the grouping of animals and the taxonomy of it all. So we're going to be talking about those animals today, what groups they consist of, where they are, some characteristics and some similarities between the different groupings of them. And then we will end with some questions, and then we'll go ahead and talk about what's coming up next in June. So, and like I mentioned, if you have any questions, please feel free to put them in the chat, or if you have comments, just make sure that they're on topic and that everyone is kind to each other. And that's what this is for. If you're not kind, or if you don't have a good idea of staying on topic, Paige does have the authority to remove you from the group today. All right. I also want to point out to everybody that I'm by no means an expert on any of the topics that I talk about. I maybe would consider myself very knowledgeable about reptiles and amphibians. So if you have a question for me and I don't know how to answer it, I will find someone that can answer that for you. So someone mentioned this the other day in a meeting, and I really like it, so I've just been using it. I'm definitely not an expert on the topic at hand, but I am an expert about how to deliver that and how to communicate scientifically to people that may that need that. So I'm not necessarily an expert on the topic, but I am an expert about science communication. So, all right, let's go ahead and get started today. So what is an ungulate? So I mentioned that they were hoofed animals, but what does that actually look like? So ungulates, when we talk about the word, it refers to animals with hooves, but the only thing is that a lot of that is very inconsistently used. So at one point, scientists are like, it's only these two groups. And then someone says, well, what about these two groups and their ancestors and the animals that are also similar to them, but they don't really have hooves? Do they belong in that group? So when we use the word ungulate, it's not necessarily it's a scientific word, but it's not a good scientific grouping of animals. For instance, like colubridae snakes, which is like the most common types of snakes that you will see, they all have similar characteristics, and they are together and they have common ancestors. The word ungulate doesn't necessarily follow that. So it's very inconsistent on how that word is actually used. But for today, we're going to be talking about two different groupings of ungulates. So one of them is going to be that Artiodactyla. Those are going to be called the even-toed. So even 2, 4, 6, 8. That's what we mean by even. And then the perissodactyls, which are going to be the odd-toed. So these are things that are very common that you probably see every day, like horses. So we're going to be talking about the structure of the hoof. Why do animals have hooves? Certain characteristics that the odd-toed and the even-toed ungulates share with each other. And like I mentioned earlier, this isn't very scientific as far as taxonomy goes, but the true ungulates, when we say true ungulates that have hooves, that apparently expanded to over 7 different current living mammalian orders. And again, it's just not very scientific when we talk about it. It is called a paraphyletic group, which simply means that this group, it contains some, but not all of those descendants of a common ancestor. So for instance, the ones that don't even have hooves, but they are ancestors to some of the other animals in this group are things like elephants or dugongs and manatees, dolphins. All of those, they actually share some similar characteristics. Whales are one of them too. If some of you are familiar, hippos actually have a very, very close relationship with whales. And when you think about a whale and a hippo, it's like, what? They don't look anything alike. They actually have a pretty good common ancestor. They're very closely knit related to each other, even though whales don't have hooves, but yet hippos do. So it's kind of an interesting word, but we're going to go with the even-toed and the odd-toed ones today. All right, so like I mentioned earlier, relationships, they're kind of artificial when we talk about ungulates, but what we don't really understand is why some of them have hooves, some of them don't. How do you characteristic that, and how do you group that together? So it's a very broad definition when we talk about those relationships, but we're going to go with, again, that odd-toed grouping and that even-toed grouping today. So we'll go ahead and start with the odd-toed one. So again, this is odd numbers, so 1, 3, 5. No animals have 5, but you get the the idea. So the odd-toed ungulates, these are again called the perissodactyl. So again, when you think of the word dactyl, you think of feet. So thinking about those different types of feet, that's really what makes those characteristics. So many of the perissodactyls, they are distributed through Africa, Asia, and the Americas. So when we talk about how they walk, the true example that I'm sure everyone has seen a horse before. I know that they aren't a native animal. We'll get to those animals here in a second. They are, those domesticated. They're not a native wild animal, but their hoof and their characteristics and their groupings and how we see them very commonly throughout Nebraska. And we're a lot of ranchers. And so we see them, and it's something that we can relate to. I promise we will get to wildlife as well today. It will not just be about horses. So, but when we look at them, they walk on what's called the terminal bones of their toes. And they also have these basically enlarged toenails. So, when we talk about a hoof, it's basically a toenail. Is when you break it down, it's an enlarged toenail, and it carries and it covers the toes that are within that into this like hard shelled keratinous grouping and substance. So the keratin, the stuff that your hair, your nails are made out of, all of that's the same kind of protein. It just looks different in different types of animals. And so that keratin has basically made those enlarged toenails, and they form the hooves. So they either walk on 3 toes, which are like the rhinos and the tapirs, or they have a single toe like a horse. And then many of these lineages are fairly old when it comes to animals, but they're either extinct in the late Eocene or the Oligocene. So it's been a while, but we can see those common ancestors, again, that paraphyletic group, and we can see those different ancestors and how they've related to each other. The ones that still remain today are the horses, the zebras, and the tapirs. All right, so I'm just going to really quickly go through these. I know we don't have horses. I know we don't have tapirs in Nebraska, but I just want to go through these really quick so that you can kind of see the characteristics between them. So these horses, the donkeys, the zebras, these are sometimes domesticated. They're sometimes wild. The donkeys are pretty much found everywhere that populations of humans exist. Same thing with domesticated animals. Zebras are a little bit more isolated in those areas, but wild populations, there are wild horses still. Africa, the Middle East, parts of Asia. I believe the only state in the United States that has true wild horses, I believe, is Montana. It's either Montana or Utah, but Montana sounds way more plausible. But these wild equids, they tend to live in open habitats such as grasslands, which is going to be seen very commonly throughout our ungulates today. Throughout those evolution of a hoofed animal, it gave them speed, and to have speed, you need lots of open space. So it kind of makes sense that the way that hooves evolved was that because they needed speed to get away from predators, and therefore you have to have space to run. So most often when you see a hoofed animal, they need a lot of open grasslands and a lot of open spaces. Currently, there's 3 species of zebras, and they are all limited to Africa. All right, and then you have the rhinos. This is some of the most intriguing animal on the planet. These are large, huge, tank-like animals. They have different types of horns. They have this thick armor skin that you can see. And then basically they're only found in Africa, India, and Indonesia. Again, those grasslands, those kind of wetlands and forests, the savannas, they do pretty much like the tropical and the subtropical areas. You're not going to find them in Nebraska, but they're very large, and they're grass eaters. So they're herbivores. They can weigh up to about 3,000 kilograms. And then depends on who you talk to and who thinks the subspecies is what. There's either 5 or 6 species, depending on who you talk to, but they belong to 4 different genera. 3 of those species are critically endangered, and then 2 of them are vulnerable, and 1 is near threatened. So normally those larger megafauna that we see here, they're normally going to be more on the vulnerable, close to extinct, critical, and any of those kind of high risk categories, mostly because of their size. Other reasons for rhinos as well, but you're going to see that it's a huge difference when we talk about hoofed animals. Some of them are so common, and some of them are more towards that high risk category. All right, and then you have tapirs. So, or tapirs, however you want to say it. I always said tapirs, and then I was corrected. So I'm sorry. So tapirs is what I've been heard. There's a single genus of tapirs. They have a total of 5 species, and they're only found in the Americas and then Southern Asia. These guys, the most characteristic feature that when you think of a tapir is this long, almost like half of an elephant type trunk that they're able to move. That's their nose. It basically helps them pick up leaves when they're in the forest or the jungle. And when they swim, yes, they swim. They're like this huge ruminant animal, but yet they're still really good swimmers. They can use it as a snorkel when they're swimming in the water. They're also nocturnal, so they only come out during the nighttime. They generally live in forests, and one of the categories as characteristics as far as them is they only are usually found near water. So if you've ever been to Omaha Zoo, it's a great place to see a tapir. 3 out of the 4 species are endangered. The 4th is listed on that IUCN Red List as vulnerable. So one of the things that I've recently learned about tapirs as well is that they're highly dangerous. So they are a herbivore. They don't have sharp teeth. They don't have sharp claws. They're fairly big animals. So they don't, I mean, they're fairly good runners, but, you know, not cheetah speed. But one of the things that I've heard about tapirs is that they're very aggressive animals. One of our videographers was telling me a few weeks ago that he went to go shoot some video, and the zookeeper said this is one of the most dangerous animals in the entire zoo when they're talking about Omaha. There's apparently been many reports, a lot of isolated incidences that they have ripped off people's limbs. So tapirs are apparently a very vicious species. So not something that they would encourage people to walk up to if you ever are out and you see one. So kind of interesting. I had no idea. All right, so that was kind of our odd-toed group. We'll talk a little bit more about them in like the anatomy of a hoof, but let's go ahead and move on to our even-toed animals. This is going to be a little bit bigger group. Most of the hoofed animals that we think of are going to be in this even-toed group. So pretty much found on every single continent except for Australia and Antarctica, but it's also very diverse. Again, 240 species, 89 genera. The other one only had 16 or 17 species, depending on how you categorize those rhinos as far as the odd-toed. So very much bigger, very much more diverse, found in lots of different places. But again, they share some very similar categories when we talk about this here. Over time, they have evolved the best digestive system of any mammal because they eat a lot of plants and plant materials. So all those tough fibrous compounds that they're eating from those plants and that plant tissue, they have to have a way to digest that. These are animals that are going to be in that suborder, those ruminants, includes all of the even-toed, except for the camels and the pigs, but they have large chambered stomachs and they undergo something called microbial fermentation. So if you remember back in like 2nd grade, you learned that cows have like 4 different stomachs. They go from one to another and then they go back, and then it's again just to digest all of those different things. But very interesting as far as being those huge animals again. All right, so your bovids, these are going to be things like your cow family, but they also include bison, sheep, goats, antelopes, oxes, all of those different types. Those are all the bovids. But this is the largest family of even-toed ungulates. And if we think about, because people, we always think about how these animals, what do they do for us and how those ecosystem services benefit us. This is the family that is going to be the most economically important to us. Again, cows, they provide a lot of things for people that we like to eat. So they're pretty economically important as far as ranching and as far as raising them goes. When we talk about those wild species, they're found in places like Africa, Asia, Europe, North America, pretty much anywhere. All of the wild males in this group grow horns. Some females will also grow horns, but not every single one does. And then the one span of horns will last their entire life of an animal. So if something happens to them, they do not regrow another one, and they don't have that sheath like a pronghorn would have. So these guys are going to have that one set of horns basically their entire life. When we also think about this, they're also found on savannas, they're found in grasslands because they eat a lot of grass. And again, those horns, they never stop growing as well. All right, another one that a lot of people forget are giraffes. So this is one of the most unique animals on Earth. Their distribution is really limited. It's only Africa, but it's south of the Saharan Desert, and also they inhabit that same type of savanna environment. So some of the big trees, the shrubs, the grasses, very similar to a lot of other large herbivores. They feed on leaves and twigs that are about 6 meters high. And then if you ever forget what family they are in the Giraffidae family. If you're also familiar with the okapi, they are also in this group. They kind of look like a mix of like a giraffe and a gray like water buffalo. They have the zebra stripes on them. They kind of look like one of those activities that you used to do, like match the animals and the feet together, and it looks like someone kind of just made an animal. If you're not sure what I'm looking at, just Google search okapi, O-K-I-A-P-I, and look at them. But these guys, they're known for those intense legs and that neck, but they still manage to run incredibly fast. So again, that's a really good characteristic. That's why hooves were invented, is because they needed to get away from those predators. So you're not going to have an animal, and it's not going to evolve if they don't use that speed. So even though they don't look like they can run very gracefully, they can run at about 30 or 40 miles an hour. All right, deer and moose. This is something a little more closer to home as far as those deer. This is going to be in the group called Cervidae family. So in Nebraska, this is going to be our white-tailed deer, our mule deer, and then also our elk species. But in Nebraska, we also do not have moose. We shouldn't have moose, even though there's been a few here. And then also like the caribou family as well. So this is all called those Cervidaes. But they're found naturally on all continents, again, except Australia and Antarctica. They do inhabit the Arctic area all the way down to the tropical environments. They do pretty well in colder regions. Nebraska is one of those. We get fairly cold here, and our deer still survive. They don't migrate. They're active throughout the winter time, but they are known by their antlers, which are grown annually. So a little bit different than the bovids, which keep theirs their entire life. As we know, you can find animal sheds, usually about tax day. It's like the day that people say, maybe a little earlier. But apart from caribou, antlers are only found in males. We know that they use those for many different reasons. Territory, mating, and courtship is one as well. All right, so this is your weird group, because they are hoofed animals, but their next closest descendant is that of like whales and the dugongs and the dolphins and porpoises. So when you think about like a hippo, again, it looks nothing like a whale, nothing like a manatee, but they are very closely related to each other. This is a very large, bulky ungulate. They're found mostly in the water. They spend a ton of time in the water. Even the babies are born and reared in the water. These groups live in huge groups, and then they have very complex levels of communication, very similar to whales. So when we think about how whales communicate, those really low, like bellowing sounds, if you've ever watched like Finding Nemo, Dory does a really good job of making those whale noises, very similar to what hippos actually do. They make a lot of those noises underwater. So they belong to the family Hippopotamidae, and that also includes like the pygmy hippos that are just a little bit smaller, but they're more closely related to dolphins and whales than any other ungulate family. So this is one that sometimes people are like, why are they in this family? Because they're not really related to those ungulates. They're more closely related to those whales, but yet they are still hoofed animals. All right, and then you have the pigs. These are things like pigs, warthogs. They have these really cool animals right here. These are your, I can't say it, babirussas, I think is how you say it. They have these incredibly neat tusks. One thing about them that I did a science of, I think it was horns and antlers. It was a few years ago. But one of the things that I learned about them is that sometimes these animals will live a very long lifetime, and their tusks grow forever until they die. And sometimes if they do not injure them or break them off, they will grow all the way back into their scalp. And that actually kills them because it grows into their brain. So it's rare, but occurrences have happened before. But they do belong to that Suidae family. Besides the warthogs who live on the savannas and the grasslands, they're pretty common everywhere else. But these guys mostly prefer forested habitats is where you're going to find a lot of like warthogs and the babirussas and the pigs, the naturally occurring pigs, not like the farm pigs. But they are found naturally in Asia, Africa, and Europe. They're mostly omnivorous, which is a little different than the other ungulates. A lot of other ungulates are strictly herbivorous. These guys will both eat omnivorous diets, so things like plant material, but then also maybe some meat as well. There are lots of scavengers, so they feed on dead or decaying animals. And then pigs and other members of this family, again, one of the characteristics they have are those large canines and those upper tusks, which is pretty unique for other ungulates as well. All right, you have camels. This also includes the group of llamas, alpacas, camels. They all belong to this ungulate family, Camelidae. So the camels are found throughout Africa, the Middle East, India, Asia, South America is home to the llamas and the alpacas. Camels are fairly unique animals as well. They've adapted very well to human populations. A lot of people don't know that you could have found them natively in Australia, but when we think about camels, we think more like an African species. So it's really interesting because they've adapted very well to people, which makes sense because people also use llamas and alpacas as well. The largest camels, they can weigh up to about 650 kilograms, but all camels have those very long legs and neck, but they're extremely well adapted to living in dry areas. A lot of people think that they will store water in their humps. They don't store water, they store fat. So a little bit different than those myths that sometimes we hear. All right, so I know that was probably just a really good overview, but seeing some of these animals and the characteristics that they share with different types of ungulates, but then also very different from different groups as well. So it's easily understandable why scientists might not group all of these animals together, especially with those whales and the hippos. But again, they all share certain characteristics as far as that hoof. So we're going to go ahead and dive into like what the anatomy of a hoof looks like and really talk about how they use that and why that has evolved over time. Is there any questions? Let's see. Reindeer family, she likes the giraffes. Okay. I think we'll just wait. Someone asked about horns and antlers. Yes. Okay. There is a special, there is a special presentation about horns and antlers. Perfect. Thank you. All right. So let's go ahead and talk about the hoofed animals now. So specifically looking at the odd-toed ones first. There's not a huge difference between the anatomy of a odd-toed animal and an even-toed animal. There's a few different changes. It's mostly just the how they distribute their weight. So I'm going to use it for example because that's what I could really find pictures of and find the good information on. I know horses are not a native wild animal, but I do want to talk about a horse hoof as far as a when we talk about that odd toe, and then we're going to compare that to a cow. They're very different, and I know not natively here, but that was the pictures that I could find, and it was something that I'm sure all of us have seen and will probably see again. So, and when I talk about it, it's not that it doesn't relate to other odd-toed animals. They're going to be the same throughout for those ones that have the single one, but things like tapirs or rhinos will have the 3 looking toes, a little bit different, but their anatomy is still going to be the same for each of those toes. All right, so let's go ahead and check out what a hoof is. So I mentioned this earlier, but when the simplest definition is when you break it down, an ungulate is an animal with hooves, and a hoof is simply an enlarged and modified toenail. So when we look at this picture here, it's a horse, but it is that keratin structure that has grown thicker in certain areas on that outside, and it encompasses those feet or those toes that are inside. So when we talk about hooves or claws and nails, they are all composed of 2 structures. So those 2 structures are called the unguis and the subunguis. So the unguis is like a scale-like plate, and basically that's your fingernail or your toenail. So if you look at your fingernail or toenail, that is the part that you see. If you've ever cut your nails too short, you might have noticed that softer layer underneath. That is called the subunguis. That's the part that has the same structure, but it's not going to be as hard as what's on the outside, because this is what protects what's underneath. So this is a very fine layer on the underside of like our fingernails, and it connects the unguis to the pad of the digit. So that is like your finger. So unlike those claws or nails, hooves are that principal point of contact between the legs and the ground. So when we think about an animal like a dog or a cat, you know that their paw pads or their pads underneath, that's what touches the ground. It's a little bit different than a hoof because it's not that hard structure. People, our skin directly touches the ground, but most of the time we're also wearing shoes, and our distribution of weight and the way that our skeleton looks is very different than that distal point of when a horse touches the ground. So as a result, it's called that ungulates have this unguligrade limbs, which simply means that when they walk, we're digigrade. So we put our feet flat on the ground. It almost is like they're walking on their tippy toes. And I have a picture to show all this as well. So when we talk about this unguis part, here's what it looks like in different types of animals. So a claw, a nail, and a hoof. So all of the same structures, all of the same names, but they're just distributed different. So animals like cats and dogs that have cats have claws. Here's what that unguis looks like. And then that subunguis is underneath. For a person, you can see what our nails look like. This is called your pad. The subunguis is going to be underneath, and then the unguis is on top. Very similar to what a hoof looks like. It's just distributed differently. So the hoof, the unguis is on top, and then the subunguis is actually what touches the bottom. So if you think about it, the bottom, nothing's going to hurt that because it's going to run into the unguis, and it's going to be that hard structure. And we'll talk a little bit more about those structures underneath that pad. All right, so that tough unguis basically encircles the tip of the digit, and it looks like a cylinder, and it encloses that unguis inside. The unguis is also harder because it doesn't wear down as quickly. The pads of the digit lie behind the hooves, and then in many artiodactyls, only the central two digits touch the ground. The lateral digits are often reduced just simply because they touch the ground or that soft terrain, and then the lateral digits are like false hooves. Sometimes people call them dew claws. So if you've ever looked at like a hoofed animal, you will notice they almost have two little finger-like things that stick out here. People call those false hooves, or those dew claws. When we talk about the unguis being harder, this is simply just because it's firm, because there's a hard leading edge to that hoof. And then when we talk about the pads of the digit that lie behind it, those pads touch the ground when we talk about the perissodactyls, but then in some artiodactyls, only the hooves bear weight. So it's just, again, it's all about how the animal distributes its weight and what touches the ground. So I have a picture. I think the next one is the picture that I will show you. But when we talk about this, why was this hoof invented? Why do we need this? Invented, like someone just made it up, but evolved. Why was this hoof evolved over time? So it's a major innovation when we talk about a running lifestyle. If you all have been familiar with like the space race and Sputnik, we always kind of refer to that as some animals and the race against each other. There's lots of different animals that evolve next to each other. So this one evolves a trait, then this one has to evolve something else, and then this one evolves, and then this one evolves. Very similar. So predators and these hoofed animals, they were getting caught, and they're like, okay, what is something? This mutation happened, and then all of a sudden they are able to run faster. And so they are able to get away. They're able to have more speed, and those predators then they had to evolve to be faster. So it's a huge innovation when we talk about a running lifestyle. So basically it pushed early ungulates ahead of fast running predators. They also have an extensive structure because they support all of their body weight on this one spot. Since only the hooves touch the ground, the rest of the parts of the hoof have to essentially become parts of the leg. So, and I'll show you a picture of how that's distributed. So how this happened, if that's part of your leg, it increases your stride length. So when a horse moves or a tapir or a rhino move, it increases their stride length because they have that hoof and how the rest of their foot has basically become the leg. And then, so the metapodal bones, the bones that are between like your wrist and ankle and your digits, they're often as long as the other parts of the leg. And then when animals raise their heel and the digits off the ground, it increases the number of joints, which move the legs forward. And then it also increases that rate of stride as well. So here's what I talk about, the weight and how those bones are distributed. So we all have the same bones. It's just how they look, how big they are, and where they're located. So a lot of people think this bone right here is the animal's knee. Not their knee, the knee is way up here. This has just become part of their leg. So as a person, that first image, our legs are almost flat on the ground, but horses and ungulates don't do that. They have that toenail that they're resting on. So these parts of the skeleton had to become something else because they weren't needed because they're not flat on the ground. So we all have the same structures. It's just how they are in the body. All right, so when we talk about a horse hoof, it's a great example of this cool engineering practice because humans, when we have them as domesticated animals, we also know that we have to maintain them and put like hooves on them. We have to trim them, very similar to like your toenails that you have now and your fingernails. You have to put maintenance on them. But the size and the weight of the horse is also relative to their hoof size. So much of their weight is supported by so little, so it has to make sense proportionally to their body. Made of the several similar parts, but they all serve a different purpose, as you just saw in that picture. And then the horse hoof basically can be broken down into 3 different parts: the outside, the underside, and then the inside of the hoof. All right, so when we talk about this outer structure, it's called the hoof wall, which is part of the hoof that you see. That's basically all you see. It's a hard, horny outer part that covers and protects the delicate structures inside. It supports the body weight of the horse and also absorbs the shock when they're running, but there are no blood vessels on the outer portion of this. Very similar to like your fingernails. If you hurt it, it's going to hurt, but there's not direct blood vessels like if you would puncture your skin. It also continuously grows, very similar to your fingernails. You have to trim them, and it's made of that keratin material. Again, it can be trimmed or naturally worn off. But again, if it's a wild horse, they're going to naturally wear it off. If it's a horse that's domesticated, they're not going to have that ability. So people will have to maintain those hooves. And then all 4 hooves on an animal are structurally designed the same. So the front and the back are the same. It doesn't matter about the weight or anything. They're all equal. All right, so then again, that outer structure, it's very inflexible. It does not move, but it does expand if an injury happens and that tissues swell inside. So if a horse were to damage that outside or the internal structure, it even could cause them to have a lameness when they walk. If you think about it, it's just to be like you hurting your foot. So even though we don't think of that hoof as a true foot, that is what they walk on. Their whole weight is supported on that. And if they damage it or injure it, it could cause a deformity for the rest of their life. Healthy hooves, you know they're healthy because they have no cracks and no rings in them when you look. Normally, the color of the hoof also is black or white. It just depends on the species and depends on the animal individually. And then the quality of the hoof is not affected by color. If you talk to, and I read some racing articles about people who race their horses, and they swear by like animals that are faster because they have black hooves or animals that they have white hooves. Structurally and scientifically, they are the exact same, just a different color. All right. So when we get from the outside, we're going to go inside. So inside there is the coronary band, which is at the top of the hoof where the hairline meets the hoof. So here's an easy way for you to see it. So where the hair meets the hoof, that's called the coronary band. This band encircles the top of the hoof wall, and it's usually a light color. You can see it. And this is the primary growth and the nutritional source for that hoof wall. So the hoof wall will grow from that side. The structure is also tough and contains a large blood supply. And then the injury to this area can cause damage to the hoof wall, and it can disrupt that growth. So it grows from the outside, just like your fingernail. And if that is damaged, your fingernail or the hoof on the horse might not grow at all. And again, leading to problems later on in that animal's life. All right, there's also something called, I'm going to pronounce this wrong, but a periple, and it's the soft area below that coronary band. So right below it, it helps protect the hoof wall. It's a very soft area, and it's made from that newly formed hoof tissue. So very similar to on a person. I don't know the names. I don't get my nails done, but when you do and look at your fingernails, right where your nail comes out from your skin, it would be like that on us. So it's a very newly formed area. It's very vulnerable, and it takes a little bit of time to harden. Same with a horse. And then that inner wall of the hoof is more pliable than the outer wall of the hoof, because again, it's holding and supporting all that body weight. All right. So underneath, when you look at the sole of the foot, so the underneath is called the sole, it protects the inner workings of the horse and the hoof, and it's designed to bear that internal weight that is transferred from the border of the sole rather than from the weight of the ground. And then if you look at this, there's something called a white line. It could actually become yellow, but it's just called a white line. And basically it's the junction between the hoof wall and the sole. So it contributes to things like protection for the animal. It helps attach the sole to the inner wall of the hoof. So when we think about how a hoof looks like when you turn it over like this person has, the underside is concave. So it dips in, and then that keratin here is much more easily worn down because that is what's continuously contacting the ground. All right, so if the white line becomes impaired, it allows germs to enter, and then it can actually separate the layer of the hoof wall from each other, again, causing problems later in life with that horse. It can eventually spread to other parts of the hoof and make the horse lame. There is a structure called the frog. So if you turn over the hoof, it's that V-shaped structure underneath, and it points down from the, sorry, that is not supposed to say that. It points down from the top of the hoof. It also protects that digital cushion. It aids in traction, circulation of the hoof and the blood vessels that are within that, and then partially a shock absorber. Not really because it's concave, but it does take a little after what's designated from the other parts of the hoof. All right, so we're really getting into this because this is science of. So this is going to be very similar to that of a even-toed ungulate, so there isn't going to be much difference. But when we talk about that under the hoof still, there are certain grooves on each side of the frog. That's what makes that V-shaped structure. The groove down the center is called the central sulcus, and the grooves on either side of the frog are the central or the lateral sulci. Just those two split each other. The bars, they're going to be extension of the hoof wall that's turned down, and it runs partway along the frog. The bars also strengthen the heel area, and it helps bend and flex that leg. So even though they're walking on their tippy toes, they're still able to move and to bend their foot just like a normal human would. And then again, that digital cushion area is something below what's called the coffin bone. So if you remember that image I showed you earlier, it's almost where that pointy part of the hoof sits. That's called the coffin bone. So it's a cushion of this cartilage material, and it acts as that main shock absorber. So if your horse is running, that's the first thing that touches the ground. So it has to have that shock absorber in it. Otherwise, you would hurt your foot. The coffin bone, sometimes called the pedal, where the pedal bone is located near the toe, and it's encapsulated within that hoof. So again, it doesn't completely have that contact with the ground. It's encapsulated within that toe or that toenail. It's the largest bone in the hoof, and it helps shape the shape of the hoof. It's also surrounded by special tissues. The distal sesamoid bone is that small bone that's actually tucked underneath and behind the coffin bone. I'll show you a picture of this too. And it helps stabilize that coffin bone and allows for some tilt on that uneven ground. So here's what it looks like when I say all of this. So the coffin bone is right here. It's the largest bone that's found. And then these are the parts that we saw earlier. But here is the coffin bone. So you kind of understand what I'm saying. The frog is located underneath. That's that V-shaped structure. Here's the cushion. Some of this other stuff that people have, your flexor tendons, people have those as well. Your bulb of your heel. Lots of these things are things that people have as well, but we don't understand how they look in a horse or a cow. So the two major tendons that support those and move those bones, very similar to people, we have the extensor tendon, and then the deep digital flexor tendon. Looks a little different, but we have them as well. That extensor one attaches to the front of the coffin bone and helps straighten the leg. And then the deep digital flexor runs down the back of the leg and wraps around this little tiny bone right here, the navicular bone. So it wraps around that and helps kind of move those legs, and it bends and flexes the leg. All right, so that was science of a hoof, more probably than you ever wanted to know about the inner workings. But again, it's basically just how those bones are distributed and how the weight and how the shock absorbing is. And again, it's just a big toenail that encapsulates all of this stuff inside. So same thing that people can do. We can stretch, we can flex it, we can bend our legs. We have the sole, we have those flexor tendons. So basically they're very similar to each other. It's just how that horse or that animal uses it. So really quick, I just want to show you the difference then between the odd ungulate and the even-toed ungulate. We saw the horse. So this is what a cow hoof looks like. So it's a little bit different. It's not a single capsule, but it's broken into two. It almost looks like they have two toes. They're very similar to each other as a horse, but there are a few differences. So there's the hard covering of the ends of the digits. Basically, this acts like the it's very similar in structure to a human fingernail, but it acts like your epidermis of your skin. So it's structurally similar, like I said, to a fingernail, but it has that connective tissue, and the cells that form are produced by tissue directly beneath the hoof wall called the corium. The nutrient-rich tissue basically contains many blood vessels and nerves. It's continually producing new cells. So at the very top, we talked about that coronary band. It pushes new cells down and out. So as soon as it pushes it out, that's very new, that's very vulnerable, soft tissue. Over time, it will harden and become kind of that toe that touches the ground. But it dies, and then it will produce a new, harder outer layer, and that's the layer that we see. All right, so when we look at a cow, you can see here's those dew claws. Sometimes people call them false hooves. But at this point, the cells are said to be cornified or sometimes keratinized. As they die, they will become hard. And then that new growth will come out of the coronary band. So up here, again, it's continually happening, very slow, but it continues to happen. The new soft growth of the surface is known as the perioflic horn, and it's very shiny, and it holds the moisture in the hoof. When we talk about how fast does this actually happen, horse hooves grow about 1/4 of an inch per month, and then cow hooves grow about 1/5 of an inch to 1/4 of an inch per month. So a little bit slower than that of a horse. But the horn then is produced due to nutrition, the health of the animal, the environmental conditions. Is it eating enough? Has it been a weird climate? Has it been dry? So all of those things, even in domesticated species, people have to worry about those too. Whoops. All right, I think this is the last slide. Okay, so this one, the hooves, basically they have these things called cloven hooves, which are these two separate ones on each foot. So horses only have one. So we saw horses have a single cylinder. Cow species or bovids are going to have two. The two hooves are referred to as claws, which are totally not right. But anatomically, they're lateral and medial claws, depending on the relationship to the body and how you're looking at it. So overall, when we talk about how is it different than a horse, The pedal bone, or that third phalange or your third digit, is called the pedal bone in most animals, but in a horse, it's known as a coffin bone, and the equine hoof. Otherwise, the function is pretty much the same. It holds the weight, it distributes shock to a different part of the body, it helps the animal run. Horses have just one continuous structure, or those even-toed the even toes have two, and then the odd toe structures have that single cylinder. Otherwise, they function pretty much the same. They look different. We have the coffin bone versus the pedal bone, but their function is the same. So when we talk about a hoof, it's basically just your fingernail, but it acts like your epidermis of your skin. All right, so that was a lot of like deep dive into ungulates and the hooves and the science of why they have them and what they're made out of. So that is actually all of ours for this winter series. Our next one's going to be starting in June 15th. It's going to be prehistoric creatures from Nebraska. We're going to talk about pollinators, aquatic plants, mountain lions, animal communication, and then we're going to finish off our summer series with clouds. So we got a good bunch coming up next this summer, I guess. All right, so same thing, if you missed this or you missed part of it, you'd like to share it with somebody, we do have a Game and Parks Education YouTube channel. All of our Science of that we've ever done in the past 2 years are on there. And a lot of you, I know when you do your evaluations, you're like, I'd love to see one on fungi, or I'd love to see one on antlers. It might already be done. So please, I really encourage you to go check out our Game and Parks channel because it should maybe be on there. And if not, we might do one. We also have a Facebook page, so it's a great way to keep up to date about what's going on and our events and some of the other things that we have happening. And then we have an Instagram, and then also that Nebraska Wildlife Education website as well. All right, so thanks everybody for that. I'm gonna go ahead and stop sharing my screen and check out questions. Someone asked so horns don't fall off and they're not made of bone. So antlers, like in the cervids or your moose, your deer, that kind of stuff, they lose them annually. And then the horns are what they have for the rest of their life. So if something injured or they're lost, they're gone. Sometimes like goats, you might just see one. That's just what they have then for the rest of their life. Someone asked like the animals at Ashfall site. So yes, so if you've ever been to the Ashfall fossil beds, they have camels, they have rhinos. So these are ancient animals that used to be here, and they were trapped in a volcano, that volcanic ash. And they're very easily, you can see the digits that they have in those hoofed animals. So very similar to what would have been a common ancestor of what's here today, or what's here in a different area. Back when Pangea was that big continent and we split up. I'm not sure how old those animals are, but it is all that information's on that website too. Someone asked which animal goes faster, the odd-toed or the even-toed. From what I gathered, horses were the fastest, or the equids were the fastest ones. So I'd probably go with the odd-toed animals. But cows also aren't super slow. Camels aren't super slow. So it might be kind of a relative question. Or an opinionated question, I guess, too. But in my opinion, I did see that horses have the fastest. So I'm going to go with odd-toed. That's a good question. Bison have horns, elk have antlers. Yes. Are pronghorn ungulates, but their own species? Yeah, so pronghorn are a very specific group of ungulates. So they do fall within being an ungulate, but they are their own family. So they are the sole living member of their family. The family is the Antilocapridae. There used to be other ones, but they've been extinct for a while. Yes, so someone said horses can run 55 miles an hour. Camels can only get up to about 35. So yeah, thank you. So I would say odd-toeds are faster. So yes, pronghorn are native to Nebraska. They're their single family. Pronghorn also are super fast. I always tell kids that pronghorn are probably the second fastest land mammal. Really, they're the fastest native animal, land mammal that we have in the in North America. I think they can sustain speeds of either about 50, 55, maybe 60 miles an hour, but they have that stamina to sustain. So we know cheetahs are probably the fastest land mammal, but they can sprint. Pronghorns are the marathon runners while also being very fast. So yeah, it's very cool. We should do a science of pronghorns. They're neat. So, okay. I think that's all we have. So I hope everyone can check out our YouTube channel. Everyone that registered for this event today, I will be sending that last email out today. And then I can give you some links to some different things that you can check out as far as ungulates go. But otherwise, you should all hopefully get an email to sign up for the ones in June and July, and we will see you in the summer. So thank you, everyone. Thanks for sticking around every week. I do appreciate that. And we hope to see you in June. So thank you, everyone. Yes, someone mentioned that pronghorns are the exception. They're kind of that weird animal. So they do have that cool keratin sheath that actually comes off, but then their horns are part of their skeleton. So yes, they're the one weird exception. So yes, thank you for making that distinction. So I would probably say the Omaha Zoo is wrong. I don't think they run that slow, but I don't know. So that could be another science of. So, all right. So thanks, everyone. We will see you hopefully in June. Hope you have a great weekend and a great rest of your week. Thanks, everyone.